at the top level of FMC solving, the best method is to reduce to a state like this. That can be solved with U, D, R2, L2, F2, and B2 moves. This is called domino reduction, and it can also look like something like this, where you do quarter turns on the R and L axis, or like this, where you do quarter turns on the F and B axis. One thing you may notice about this moveset is that this moveset only permutes these four edges around the equator, without affecting the orientation. In particular, these edges will never mix with the U and D layers. And so the general consensus on how to deal with a state like this is to first focus on the U and D layers, just ignoring the E slice, and then try to insert E slices in the skeleton. So you reduce to something like this is called a leaf slice, and then reduce E slices. And the reason this works is that doing an E slice doesn't really affect the progression of the U and D layers. And also because there's going to be many U and D moves, you can often cancel. And so you can often do this insertion in +0, +1 moves, sometimes +2, very rarely +3 will be necessary. Now, how do you actually find the optimal insertions? This isn't like normal FMC insertions where you just follow some pieces around, insert an algorithm. This is much weirder. So before I came along, the only real way to do this would be brute forcing. Just try all possible +0s, all possible +1s, and so on. That's not quite true. You can also sometimes do a suboptimal insertion and then use Sebastiano-Trento slice theory to reduce the size of the final solution. But it's not possible to prove that you found optimal unless you get a +0, and no leaf slice skeletons have a +0. Now, on January 22nd, 2025, I proposed another way to do this, a more systematic and mathematically motivated, which is called VR. VR is an acronym which stands for Vierergruppe reduction. Vierergruppe is a German word, which means group of four. And what are these for? What is this for? These are four permutations of the E slice. You have the do nothing, this 2e2e, this 2e2e, and this 2e2e. And this can also look like something like this, where the centers are scrambled for a Y2 way. It can be in only one way due to parity restrictions. Now, the way VR works is that you insert E and E slices, E and E prime slices, to reduce to one of these 8. And then you solve this only using E2s. And this group has mathematical properties that allow this method to work. You're going to have to try multiple VRs in order to get the optimal solution. So there's still some brute forcing involved, but the amount of brute forcing is much, much, much reduced, which is one of the pros of this method. Now, this method is dark magic. I'm not gonna. It's hard to understand how this works unless you have some background in group theory. And I would like this video series to be both a video explaining how to do this practically for people who don't have the background, but also a video explaining the theory maxing for those who do have the background and would like to have this method motivated. So at the beginning of the video, I'm gonna tell you whether you can watch this without really knowing group theory, or whether you can. So if you have skill issues, you can just skip all the mathematics videos. And if you're a theory maxer, you can have VR motivated to you so that you could have discovered yourself. If you just had a mid-lay lol.